Next talk from Jay. It looks like we're gonna get a demo.
Yeah, this is gonna be like in the latter part of the talk. So
all right, okay.
I'll prepare this slightly and then like turn back to the slides.
Okay, so Jay's gonna be talking about semantically grounded visualization of React hooks.
Yeah. Great. Hi everyone. I'm Jay Lee from Seoul National University, and yeah, I'd like to talk to you about a semantically grounded visualization of React hooks. So this is a joint work with my master's advisor, Carnegie, and yeah. So today, React is the go-to framework for building web user interfaces, right? And in a recent Stack Overflow developer survey, about half of the developers said they use React. But for those of you missed it, I'll give you a whirlwind tour of React. So let's say you want to build a simple counterexample. When the user clicks the button, the number should be incremented by 1. So in traditional imperative UI programming, you'd need to implement the internal state and then manually update the UI after the state update. And as you can imagine, as the UI gets more complex, it's easy to create a bug where the UI and the state gets out of sync. So React frees the developers from this burden by automatically updating the UI when the state updates. And in React, we divide and conquer the UI to be rendered on screen into a view hierarchy. So for us programmers, this allows us to compose smaller views to build rich UI. And for React, it allows the runtime to efficiently update only part of the UI when the state changes. And a component is a specification of a view that describes how it should look and behave. And it is simply a JavaScript function. So what does it look like? Here's a simple recursive component called bin, short for binary tree, which gets rendered as 2 and stars on screen. So like bin, all components should be fully declarative. So as a manual for a view, React wants the component to read it. But a mere act of reading a manual shouldn't trigger a side effect. I mean, if reading a manual for your fridge, open the fridge door, you'll get surprised, right? It's the same for React. React expects all components functions to be free of side effects. But any non-trivial UI needs to interact with the user, which is inherently effectful. So React provides a controlled way to declare side effects through React hooks. Today we focus on 2 fundamental hooks, useState and useEffect. So useEffect manages component state. It takes initial value as input and then returns the current state value and the setter function. So for React to see the update, you need to pass an update closure or an updater function to the setter function. And useEffect runs the provided closure called an effect, which is going to run after each render. And here's the problem. The semantics of React and React hooks are quite subtle. So a component is like a fork. It's a single function playing 2 related but distinct rules. So what do I mean by that? So initially, React calls a component to construct a new view. And this is used to render the view for the first time. And subsequently, the same function can be called, possibly with a different argument, to update an existing view. And this dual nature can be confusing because the same function behaves differently depending on the lifecycle phase. So here's a counter component to demonstrate this. So when first called, useState uses the argument x to initialize the state s. And when the user clicks the counter, it triggers a re-render, causing React to run the counter again. But this time, useState performs a different task of returning the existing state's value instead of initializing it. And even experienced React developers confuse the semantics of hooks. In fact, the most visited question with the React hooks tag on Stack Overflow asks about useState semantics. So this is a code snippet distilled from those questions. And this counter increments the number by 2 every time it's clicked, unlike the previous example. So let's try to guess the order of the printed logs. So I'll give you a couple seconds to take a look at this code. So when React first calls it, it's going to print counter and then initialize the state, followed by printing return. And as you can see, there's on-click handler provided the button, which has 2 calls to setter functions, each of which is provided with an updater function that increments the state by 1. And the second one has this mysterious console log update. So what had happened after the button is clicked? So will it be like update, counter return or counter update return, or will counter return update appear in the console? So I'll give you a couple seconds. So actually, without knowing the actual semantics of hooks, any of these traces is possible. Right? And the actual trace is going to be counter update return because state updates happen at the corresponding use state call site. But as you can see, this can be quite subtle for those who are not familiar with React and even experienced developers. So to explain and precisely understand these kind of semantics, we came up with an operational semantics of hooks that clarifies these kind of behaviors. And based on the semantics, we've built a visualizer on top of it to explain like how components render step by step. So let's turn back to the previous example and see how it works in action using our interactive visualizer. So I have it prepared here. So this time we're not using JavaScript syntax. We're using a simple applicative language syntax that extracts the essence of hooks. As you can see, I've also added the use effect call to demonstrate like how it affects the visualizer. So let's take a look. So initially the argument 42 is provided. So we actually show that this is in the initialization phase by showing it in the slightly faded region. And so you can, on the third pane, we can see the description of what is happening. And we're trying to render it for the first time. So now counter is printed. And then we're gonna initialize the state. So as you can see, after initialization, we have the new state with label 0 with the initial value 42. And then return is going to be printed. And now it is mounted. And as you can see, that is the green light bulb is showing that the effect is going to be run once the view has been mounted. So now the view has been mounted. So it has two children. The first S is showing the number 42. And there's this button, which will call 2 calls to the setter function. So let's see what happens after the button is clicked. So if you press the button, we can see that there are more steps to be executed. So now the state update is queued. So as you can see, the red light bulb is showing that, oh, the setter has been called, meaning that it has to be processed during the next run. And even though we have processed the setter function, we did not see the update getting logged, right? So now the user can see, oh, this update is not printed right now. So it may be like processed during the next render. So during the next render, the counter is going to be logged. And then followed by state updates, which includes a call to the print update. So now the update is logged. Then effect is scheduled, and the return is printed. And because it has been rendered again, okay, the effect is printed. So yeah, that's how our React Trace Visualizer works. And yeah, let's discuss.
Okay, 4 minutes of small group discussion, 3 minutes of whole group. See you in 4 minutes.
Yeah, how many questions can I get?
I think we probably have time for 2 or 3 depending on how long.
Please.
So, we were 2 people that have done a lot of React and learned something, so thank you for that.
Amazing.
But also, I was kind of thinking, like, in the sense that this is potentially a pedagogical tool, is that a problem? Because the fact that people know that uState is deferred is really confusing for students. The fact that uState is deferred precisely to the point of use state function executing again in the re-render was not my full mental model of React, I think it's most people's. Does the difference, like, are we confident that teaching people the real model of how React works is going to be easier than the, like, kind of broken one that I've been working with pretty well?
That's a fair point. Like, proper React applications should work like with any mental models, right? Like it can. You should know that it is deferred, but maybe it should work regardless of the mental model with the setter functions process right at the call site, right? But still, for me, it was kind of important to like precisely like grok the behavior of use state and like hooks. So I think it depends. Like if you are trying to like teach that, I think this can be one method. And if you think, yeah, I think it's an open question, like whether students will like, appreciate it or like it's not. It's too fine-grained.
There's a quick follow-up. I think this relates to Harriet's earlier talk about like specifications. Like kind of the question being, should we be teaching people a very specific, super concrete semantics of React, or a broader specification that could actually describe like many different possible semantics, but like constrains them to like basically like whatever the documentation says. Right?
Yeah. So I think like students may be writing like a lot of. If you're not really used to React, you're gonna write a lot of really bad code, but like really creative code. So like you'll get so like you'll do a lot of things like printing inside the updater functions and then like get surprised because this is not what I thought it would like perform, you know? So I think it can be good to like let the students know like this is actually how it works under the hood.
Okay, thanks, Jay.